Welcome, welcome everyone. I will start to talk right now, so enjoy your seat and enjoy the talk. So, since the Stone Age, we as a human, we have done the tremendous progress in using the tools. It already started with using the stone tools. For what? We wanted to create something. Well, we wanted to sustain our lives in order to make a food better, taste better, and in order to get the food, to get the animal, right? We put it into the next level at around the 19th century, right? When the Industrial Revolution has started. We created a way more complex tool, basically mechanical tools, and we built those tools in order to sustain more lives, right? In the Stone Age, it was more individuals focused. And the beginning of the Industrial Revolution, it was like group focused. So when we move further and around the 1950, where the second phase of the Industrial Revolution started, we produced way more complex mechanical tools. But what is also nice, we precisely try to plan the material per these units we produce that help us to sustain way more lives, the population, and we started to concentrate this. And we come along a way from there, and we are right now here, and we are able to produce way more complex tools. And it's like with the electricity, when electricity got introduced, it was like a boom, right? The internet has been founded, the programming languages and everything. Those mechanical tools have been right now, since the moment, computer controlled, and transistors and so on. So we've been able to produce way better gadgets to actually maintain the populations. And those gadgets, they have actually the similar dominators there. Yes, one of those are nowadays the software, which we run the software where mostly in data centers. And it consumes a lot of energy because previously we've been taking precisely about the material units we have to have. But right now we just stop, we deploy, you know, we have a CI/CD pipelines, right? We deploy there, we don't care, it's somewhere. There is a data center from Google in Oregon, right? These kind of green energy, green solar panels is fully feeding those servers. And we stop care, it's deployed, it's there, it's in a cloud, it works. But right now the oxygen emission, carbon dioxide emission, they are rising up actually. So we need to take it into the equation, the software we develop, and how many times we actually refresh our VMs there. And we can do it better, right? We can reduce it. And the way how we can reduce this is a similar approach like we then have done in the Stone Age, like with the tools. It's a patterns. We call it habits. It helps us to kind of keep calm in daily job, right? Because we don't have to think about the patterns. They are there, we learn them, we train them, and they keep our brain free. Okay, so today talk about how to boost the delivery stream with code discipline engineering. My name is Miro Wengner. I am involved in Java ecosystem for many years, actually for decades. And recently I have written the book about practical design patterns for Java developers, but it's not for there only. And it's also my intent is how to contribute to a green approach of the software development. I am working for amazing company Open Value, and we there already making a lot of thoughts about the green software and how from the small scale to the big one. So let's add the safe harbor statement that no one gets offended by data they're going to be published. And let's take a look on the agenda. First, I create kind of situation, model the situation, and we go from the discrimination to the way how we can understand the software and how we can understand the patterns. Recently published study by InfoQ shows the tendency of the software company to assimilate the functional programming approaches. It's like it's a ACA-like structure, actors, and also the data-driven application. Because right now the requirements of the business, right? There's the times when we develop the really software for the small unit are gone. Right now the software is running on multiple JVMs, so it's not isolated anymore, and therefore as it's spread around, we need to also find a way how to communicate. So sometimes I hear at my work, okay, it's a bad code. I think everyone kind of reached this stage, and everyone heard something about the Conway law, right? The software that company produce, in other words, is the projection of the way how the managers or how the management communicates, or internal communication of the company, how developer between themselves. But this is just a part of the truth, because I found out that many times it's about the similar language that the developers or the manager cannot talk to each other. Yeah, so it's I know it could be the communication, right? But it's a little bit more how to approach, how to tackle the challenge. So recently another published study shows the price of the bad code. It's from 2018, and they have done very much companies, but it also shows that the cost of the bad code, suboptimal code, is around $300 billion per year for American companies at that time. So it's a bunch of the money, and it is covering the technical depths and the legacy code that needs to be maintained, and the impact of the suboptimal solution. Well, and it also shows, after closer unlook, that actually only 57% of the developer's time, of the engineering time, is actually spent effectively. Oh, it's so bad. So, and the cure is actually lying here. We already heard many years ago at the university time, right? We already heard the abbreviation IPI. So it's a abstraction, polymorphism, inheritance, and encapsulation. But actually what we didn't hear is that it could be taken from the other way around, and we start first as a developers or just the manager to encapsulate the issue, precisely define. Then we can inherit it, we can just kind of evolve our idea. Then we can find out that we actually need to overload some implementation, the polymorphism, and then when we are here, right now, it's a great time to start to generalize, to make the abstraction. And you see here already this concept, which is known, already taking care about not repeating itself and taking a code dry. If I put it into the different projection is here. I start with encapsulating my idea, yeah, basically the requirements I have. I kind of evolve my idea. I can apply the behavior on the demand of particle objects, and then I abstract. I can put it into a timeline, but it already sounds like a cycle, right? And many of us works in a sprint. And sprints are here because we don't know at the time T1 all the requirements, right? So, and we need to evolve the support in the cycle. So it's already here, and it was here anytime, but we have forgotten. And most of the time when we find it out that it's been here and trying to apply it, it turns into something like a Dunning-Kruger effect. Yeah, that someone already knows, he got the kind of enlightening, right? And he reached the peak, right? And he tries to share his excitement with everyone. But there are 2 points. So it might hit the level of kind of missing knowledge from the technical perspective, and also the missing points from the business perspective. Yeah, actually what we need to do is get the proper knowledge about our technology stack and about our business and put them together in practice. And this may feel like we end up in the valley of despair. So we are just keep struggling, and this is why the Dunning-Kruger effect is here. What I've been thinking the first time when I draw this pyramid, actually, I thought that this is I have realized something new, yeah? There's a project happiness, yeah? But actually, when I thought more later, after, so you see the information span that you need to have about your project you are working on, about your goal or target, it's very bright. You probably, if you are working alone developer on a really small located problem, yeah, that's not that big. But if you are working in a group, yeah, it's very big and it's very hard to maintain this in one hand. So you need to work in the team, and that means the domain knowledge is bright and it's got a little bit closer, thinner, right? When the tooling you used and when the requirement streams you have that are coming from the management and the innovation, like delivering our application into our JVMs, just deployment process. But on the top of that is a small learned habits which we call the discipline, right? It's a smaller because they repeat like in a cycle. But if it goes then down, yeah, as you know, the developer, there's the arrow begin down because you are working on basically small part of the application. You see, so the discipline actually to fix the problems which comes from the architecture of wrong suboptimal decision is very hard. You see, it's very small, the domain architecture decision of the anti-patterns, but it requires tremendous amount of the discipline of developers to fix them, to remove them. And it's way easier to remove anti-patterns from the requirement stream, which is basically more from the particular parts and the code and the modules you do have. And we will talk about this later. So sometimes, right, it feels like when you work on project in MySQL, it's like the domino. It's again the cycle. This domino is created by Lego EV Dry, right? Then what is funny on this? So you can just put it down, it all fell down, and you can stand it up and repeat. So I know these anti-patterns, like you heard also, keep it simple, just deliver the ticket, close, but keep it simple. It's one of the most, is it really simple? Then to remove this simplicity. And many times it works on my machine, so cool. And the most I loved one, fake it until they make it. Yeah, it's you can apply this, yeah, but actually when you start working on project which does not allow it and which requires to have precisely defined the best behavior of your application, this is not possible. And you get the rejected your pull requests. So, and also if you try to accumulating the technical depths, so when you're gonna fix them? Never. And I have spent many hours of discussion about why not there, why not to bite the forbidden apple, yeah? And it's repeating like this domino. And the definition of the anti-pattern is, yeah, it's a very highly risky code, right? Counterproductive steps and so on. But what is more happening here when we try to apply them is we are actually limiting ourselves, yeah? Even you, even me as an individual, to address properly the challenge we are facing, to communicate it, to make it visible for others. That's what is happening. And it may end up in something I call hot fixes cycle. Yeah? You are fixing kind of technical debt by the other technical debt. And this remains in the loop for a very long time until someone realizes that is actually wrongly used technology or wrongly understood requirements by the product management. Yeah, and what is more happening here using the passive, we keep squeezing the tooling we used and platform, which is also not good. But it's great that the Java architect, the language architect, really thought a lot about this. And if you do remember the study I have published right now, the InfoQ about the tendency of implementing the functional paradigm inside of project, this is a very nice response from our new Java 21 LTS edition. There is, you can feel it, this pattern matching for the switch case. Yeah, it's a dramatic, enormous power is given to you right now, because right now you can get rid of ineffective code you had to do it before, and it's right now, it's a right time to do this, because the business requirements, the industrial requirements are actually requiring for you to do the data mapping, yeah, and kind of streaming of the data, yeah, and in the functional way. So when I talk about these the anti-patterns in the code, right, and the pyramid, yes, it is on the top. It is they are very easy to identify. What is very nice on the anti-patterns is that they are many of those, and they are well described, and they are actually, when it happens, yeah, the developers basically feel it, yeah, and this is why I'm saying this. Just give them the name and address this issue, and if you have a name for the kind of obscure implementation in your code, you can address this, and this name doesn't have a feeling, you know, so discussion doesn't go emotional. And what I want to say also, sometimes the anti-patterns not necessarily have to be bad, yeah. So why I'm saying this, because you need to move forward, progress forward, right? Sometimes you really need to copy code from the past, but you need to identify and make at least the to-do comments that needs to be removed in the next iteration. This is why I'm saying that anti-patterns are not necessarily bad. They can support the progress, but they need to have a name and be properly identified there and not forgotten. So according to this, the anti-patterns that may reside in the domain knowledge, do you remember the arrow? They are very hard. They may be centrally extremely expensive to remove them. As I mentioned, you have to, any line of code you will write, you need to maintain. So, and if these anti-patterns reside in the domain knowledge, it will spread upstream. And it will be required to have multiple people working on the multiple modules to remove them. So they are significantly hard. This is why it's very nice when you have a name for them and we can identify them, spread them, and add them into the cycle. Yeah, everyone knows the golden hammer, you know. I have some such of those. This part of code works. You don't have to change it. Please use it. Okay, well, until it's too late. And all of these turns into the squeezing a platform pretty badly, actually. Yeah, and the tooling, because I know this is the funny things in the team. I have people, yeah, we are using some Scala akka on one project, and they told me I never get, I use the akka, I know it's described like it works like this, but I never get into realize how it involves the JVM itself, because it runs the JVM, right? So you still have to have some knowledge about where it is executed, because your code gonna be executed on the machine. So the fact that it's described like this not necessarily have to be right, because as it's a software, right? Software has also the evolution cycle. There are known bugs there. So the fact that you know particular tool doesn't exclude you from know the platform where it is executed. And this is the funny story here, how you can do this. And the nice thing is, I have observed it on Kotlin platform and Scala platform. The reason for that is because they imported some Java libraries into this. So, but it's not only the reason, because you can do this also, unluckily, in those other JVM languages too. But this is obvious path. So maybe you see already the issue. Where is it? The sensor record. Yeah, it's immutable, but it has a primitive value here, which primitive values are not really used. The primitive types are not used for collections, so it will keep squeezing very platform, because the collection is actually initiated in the heap, right? So everything what goes there, so needs to be like objects. That means autoboxing will, the primitive type will be converted into the wrapper, which is the integer. And it will keep doing this in this particular case to the garbage collector. Not nice stuff. So the funny thing on this, the Java platform has already implemented a lot of caching here. So basically the object, or you have references to particular set of very often used numbers in this case, so you don't have to like create a new one, right? And in this particular case, the fix is very simple. Just change one line of code, and then your garbage collector is really happy about this. Yeah, you don't have anything, but you need to identify this line, right? And this is why you should, well, it's a recommended, like with the stone tools in the Stone Age, to follow some habits, some patterns, to identify, to name this, and to get healthy your project or your particular code. And this is Andy Warburg. It was the art historian and culture scientist. He said, der liebe Gott steckt im Detail. Yeah, the translation to English is very simple. The evil is in the detail, right? And it's so true, because it was just a one type change and it fixed our project. And this sometimes is happened also in the domain as a simply different perspective on the implementation may change, may be the break changer. And this allows us to jump to the solid design of the code, which is already there. I will show you. We already know it. We have a feeling for that. I know that someone is coming, okay, this code is bad because it doesn't respect the single responsibility principle, or just it's very open and not closed at all. So imagine you are building a car, right? You have your particle cards. It's just imagine the car. It's very precisely defined tool, right? And you can evolve it, right? Because you have defined the parts, and you can just expand it, you can do the facelift, and you can go with the car to any wash machine, right? And you don't force, you have no two radios in a car, right? Normally you have a one, so you don't force the user to have two radios. Okay, you can have it. I saw maybe some tuners, they do this on the purpose, yeah, but normally they don't. And also the car has basically only feature it requires, right? Basically I required it has a steering wheel and 4 wheels, and I can drive it from point A to B. And this is when I say, like, you have in a car some backup systems, yeah, when the one sensors go out, but you don't repeat it in a way that you're gonna have on the right like 4 lights and on the left just 1. Yeah, so it's still valid. These solid principles allows you to keep your code dry, and the effort you give, you get back, because your application becomes to be more secure and, what more important, more maintainable. Yeah. So the cost for the maintainability really currently rising up, and it may have bad impact to the projects itself. And if I put it back to the loop, right, you see, you already saw it, right, with the IPy. So we have here single responsibility principle, open, close, and then it feels like it was always here. Although we didn't know the name, what is behind the letter solid, we got it here, and it's again like a cycle. And it feels like it fits our sprints. And we can iterate and move forward. Whatever we have done, just bad code, so we can move forward and fix it. We get a name. And this leads me just the coding standards in the working software, based on they are just inevitable. So you cannot get rid of them. If you would love to produce the software that you can share with across the teams, your peers, and so on, you need to develop some habits. And having them, it gives you like a Stargate, like a jump. It really makes joy with working with a project. And also the joy with having a conversation, not about how I fix the bug, but about how we evolve, like in the way of optimism, which is required because the work is stressful by the definition itself. So as we see, we have right now already given some kind of types of the patterns that has been identified in the past. And I can say, like right now, as I said, the company is trying to apply the functional approaches to it, which automatically behind the scene implies that there will be a lot of concurrency, and it's not going to be less, right? And this is why the concurrency is staying on the top. But to get there, it requires to fulfill first the levels on the bottom, because the concurrency is very hard. And although some framework may look like, oh, this is the holy grail, like Akka or something, some other framework concurrency, or this is the holy grail, how to fix my concurrency, it's way more complicated behind the scene. Not necessarily. So this is why it is hard. You still need to know what is happening. You cannot just say, okay, they do this like this, I just read it on the Stack Overflow, because then you have undescribed behavior and you will be asked by the customer how it behaves. Can you describe me precisely how the threads work together? And this is, for example, one of the patterns, which is a bulking pattern, which is sometimes what developers want to achieve, is to have the only one to the critical section. Right now is a scenario where we have just the one car, 5 drivers, and the preparation phase and the execution phase. And you see on the image there, the thread is that it works. Only just one driver can drive at the time, right? Yeah, but the first to go there, we need to fulfill the requirements. We need to first nicely create our objects. And you see here, right now we are stopping exactly in the requirement stream, when it resides. The requirement stream is mostly about, before we do mapping, we need to still create the entities, right? And we need to have a control about the creation. And the most of time, like a good approach is to start with the factory, right? Because the factory just hide behind the scene of the process of creation, and we can move and iterate in the sprints over, and we can go and create more complex building process with the builder. As you see, again, the factory with the new features of the 21 edition became really simple and way less code. We can get rid of the obscurancy we already implemented and just use the switch cases, pattern matching, and direct access to the values, and make our code simpler, more functional. You see, again, according to the business requirements current. And if we would love to have the better process on the road, we across the methods, some more complex, we use the builder. And of course, the records has been selling point, that's an immutable object and the VVM, but still, there is the way how to fake it by the atomic references, basically avoiding the memory check. And please don't do this. It's a great idea how to fix particle problem, which is signaling already wrong architectural decision still on the stream level. It's easy to fix. But it's better to reconsider your decision instead of following this path, because when it becomes to be a problem of the business knowledge, that is very hard to remove, which I'm getting here, the structural patterns. They are, again, just a little bit less to describe, yeah, but they are like a Lego. Right now we already built up the pieces together, just as small, and we can combine them. So right now we really getting into the business. Yeah, you see the structural patterns are kind of interconnecting the shift from the requirement stream where we have created our entities to the domain knowledge. And like a Lego, we have prepared our stuff lying on the table, and we just properly need to name it and put it together. I just choose here the adapter because it's a nice example how to very cleanly represent it by the new features we have. And you see here also the switch case and the composition of the entity gives us the direct access to the fields we do have. So it's not that simple. It's very less code. It can be done straight away after the meeting based on the requirements. And we go here. So according to them, here we are entering the behavior design patterns, which are harder because right now they are actually already hitting the domain knowledge. We need to be precise on what and how we connect the structures, visually the architecture code structure we have created and the entities, and we put them into the process. So right now we have really the card, just probably small pieces, yeah, of functional working puzzle of our entire domain knowledge. Yeah, the domain knowledge is like a puzzle. So you don't see on the table, on the surface, all of those. You just have nice pieces. They have to fit together. Some of those through the APIs, some of those another communication lines. Just like a modules, like a puzzle, they fit together and we get the car, right? To be worked. So here I identify based on my experience is as the many times we simply need to cache the stuff. So although we try to apply the stateless yeah, approach to our entities, the many times actually we require to hold the states, and it doesn't matter if it is Scala, Kotlin or Java. So they simply approach it a little bit differently, but there is still possibility to do this. Yeah, to cache the current value, and sometimes we are in a shape to use the caches like externals, like a Redis or in another in-memory solutions, and sometimes it's a too overkill to use it. So we need to use the array and kind of handle the elements in this fashion. And as you can see here, again, here comes the new feature into the play, because, for example, the records, which are actually meant as the immutable elements, right? You can decompose them, and as in Kotlin or Scala, you can directly access the internal field and use them for your next steps. So, and I'm pretty sure, and I feel there are still projects that are running Java 8, yeah, or just even older, yeah. But many of companies, they already made the shift to the 17s, and many of those they will in very near future do the 21, because it produces less bytecode and it reduces even 1% of reduction of the computation time which are running in the cloud. It is a lot of money. It depends, of course, on the scale, but you can calculate it. And you can hire more people or buy a new coffee machine. So, therefore, the evolution is inevitable. So, conclusion to my talk. So, the discipline on the habits, actually how we do code, they'll help us to kind of not only maintain our mental healthiness, but they are also allow us to communicate precisely, to name the address the issue actually within a team and outside of team. Also, they positively involve the innovation if we would love to redesign our pipelines, redesign our code, and that therefore they have a direct impact to the maintainability, again the cost reduction, and they help actually not only us, also to management to address the requirements, right, which can be broader, and they will be separated on the team and improve the new tooling that we would love to have, and all these fit to the general puzzle, which is the domain knowledge where we work. And at the end, most effective communication. I know many of us, we have experience sitting on the meeting for 1 hour, and actually the outcome is that we are actually very sleepy and bored, and some of us got excited. So, and this is mostly because we cannot maintain our brain to be work when especially on certain topics. So that means that in discipline improve the joy and happiness in the project. And I will thank you. And I have one question. If anyone spot what I have forgotten on the slide of solid, which kind of letters and knows, I will give him book. Yeah?
The letter D was missing.
Yes, that's true. Here's the winner. Okay, maybe everyone knows it. Here. So that's fine. It's a dependency inversion. Yes, and it was missing. Just it's a forcing to project has the feature that you really don't know. Like I don't even have to know free CD players in the car. So yeah, it fits to the abstraction. Yeah, but the IPy has only 4 boxes, so I remind the 4 boxes. So thank you very much right now. I hope I give you some idea how to approach your project and your challenges you have at work. And thank you very much for being here.